AI Frontiers presents Robotics on the Rise, Navigating Complexity. We're diving deep into 18 robotics papers released on November 22nd and 23rd, 2025, focusing specifically on the latest in cs.RO research. Today's journey involves mapping the exciting landscape of recent robotics advancements. We'll set the stage by exploring the world of robotics, then identify dominant themes, key breakthroughs, and the methodologies driving innovation. Finally, we'll spotlight seminal papers and chart the course for future research. Computer science and robotics is where intelligence meets physical embodiment. This field focuses on intelligent systems, particularly those housed in physical robots, enabling them to perceive, reason, act, and interact with the world. It bridges algorithms with physical realities, driving innovation in autonomous systems and proving crucial for real-world applications. Our first dominant theme is enhancing robot autonomy and decision-making in complex, dynamic environments. Robots must operate safely amidst uncertainty, and this research focuses on predictable obstacle behavior. A key paper by Liang and colleagues introduces frameworks for formal safety guarantees, critical for unpredictable real-world scenarios. Next, we're advancing robotic manipulation and assembly, excelling in intricate processes, especially for delicate tasks like snap-fit actions. The work by Kumar and his team on dual-arm coordination focuses on detecting engagement and rapidly adjusting forces, which is crucial for manufacturing and electronics. A third prominent theme is integrating perception with action, often termed vision-language action, or VLA models. This allows robots to learn to see and act intelligently, with a focus on active perception for improved observations. Key papers like Observer-Actor by Wang et al. And Echo-VLA by Lin et al. Integrate memory systems for long-horizon tasks, coordinating navigation and manipulation. Let's highlight some key findings and transformative breakthroughs. We've seen formally guaranteed safe motion planning in dynamic environments from Liang et al. There's also real-time, sensor-agnostic detection of delicate assembly events by Kumar et al. Furthermore, bridging language instructions to complex long-horizon robot control is advanced by Lin et al. And Huang et al., alongside enhanced robot learning and control strategies for resilience from Lourenco et al. And Som et al., and sophisticated 3D representations for simulation and action from Wang et al. The methodologies driving these innovations are diverse. We see extensive use of machine learning, particularly deep learning, for pattern recognition and control. Probabilistic reasoning and uncertainty quantification are employed for safety. Model-based control and dynamics modeling provide physical understanding, while reinforcement learning is used for learning complex policies. Finally, 3D representations and rendering techniques are vital for simulation and vision. Our first seminal paper is Time-Aware Motion Planning in Dynamic Environments with Conformal Prediction by Liang et al. This work addresses safe navigation with uncertain moving obstacles, integrating conformal prediction for robust, distribution-free safety guarantees. A key technique is the adaptive quantile mechanism for risk management, enhancing reliability for autonomous vehicles and disaster response. Next, we examine a coordinated dual-arm framework for delicate snap-fit assemblies by Kumar et al. This paper solves precision challenges in delicate robotic assembly by introducing SnapNet for engagement detection via joint velocities using sensor-light proprioceptive sensing. Their coordinated framework with event-triggered impedance modulation achieved over 96% detection accuracy and significantly reduced impact forces. My third seminal paper is Observer-Actor, Active Vision Imitation Learning, with sparse-view Gaussian splatting by Yilong Wang et al. This framework enables robots to actively choose optimal viewpoints using 3D Gaussian splatting for scene representation, improving imitation learning robustness against occlusions. With dynamic role assignment between observer and actor arms, it achieved over a 230% improvement in occluded scenarios. Looking ahead, future directions in robotics include continued focus on robustness and safety guarantees, enhanced memory and reasoning for complex tasks, and efficient adaptive learning methods like continual learning. We anticipate seamless and intuitive human-robot collaboration alongside the development of standardized benchmarks for objective evaluation. This AI synthesis and review was crafted using AI tools, including Google's Gemini 2.5 Flash Lite, with TTS synthesis powered by Deepgram and image generation by Grok. Human expert review ensured narrative coherence and accuracy, and all references are provided for transparency, with potential oversights acknowledged. Stay connected with AI Frontiers for more cutting-edge AI insights. Don't miss our weekly deep dives and subscribe to our YouTube channel. Engage with our community online and discover the latest in AI research. Join the conversation. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.